We'd like to continue our discussion of object-oriented programming and classes by introducing functions to the class definition. This is the code that describes a class in C++. It is essentially an outline of the class, including the name of the class, the private data members, and the public functions, member functions. The first line in the definition begins with the C++ keyword class that tells the compiler that we are defining a class of objects, and that is followed by the name of the class, which has to be a valid C++ label, and it should be a name that represents what you're trying to describe with this object. For this example, I'm describing a rectangle. The first item in the description of the class is the private data members of the class. These are listed as private, so we can only access these values through the functions listed below in the list of public member functions. I'm describing a rectangle, and the two characteristics I'm using to describe this rectangle are the width and the height of the rectangle. So I'm going to use type double numbers for those for that description. So the keyword is private, followed by a semicolon, and then a list of the variables and the data types that describe the class. These look exactly like variable declarations. In this case, type double, but it could be any other data type that is useful. And then a variable name, again, has to be a valid C++ label, and it should be descriptive of what you're trying to describe. And it's written here. They are written on one line. Normally we would have put those on two lines, but I'm trying to save a little space on the slide. The next part of the class description is listed as public with the C++ keyword public, public, then a colon, and this is the list of member functions in the class. Now, these are declarations of the functions, and only one of these functions is completely defined in this listing. These are the names of the functions, and the other information about the functions. This is telling the compiler the names of the functions that will be in this class. The description of the operations that are performed by these functions are in other bits of code that we will go through later. You should be able to find on Blackboard the code listing if you want to see all of the code put together and how that goes. So these are the member functions. They're all listed as public, which means that we have access to these functions by means of function calls from the main function of our program. They follow either one of two forms. The first two functions are constructor functions, and it says class name and parameters. I should perhaps say function name in that spot and parameters. But for a constructor function, the class name and the function name are the same. So those are the first two functions, and the remaining functions are functions that we can access through function calls from the main function, and they follow the form of a return type, and then a function name, and then the list of parameters inside the parentheses. And some of them take parameters and some of them do not take parameters, just depending upon the circumstances of each of the functions. The first two functions in the list of public member functions are the constructor functions for this class of object. And the constructor functions always have a name that matches the name of the class. So for the constructor functions, the format is you have the class name, which is, you could also in this context call that the function name. And then there are a list of parameters in the parentheses. The first is the default constructor function that has no parameters, and I think we'll look at that in the next slide. And then there is a second constructor that does take parameters. The default constructor function takes the form of first the function name, which for a constructor function always matches the class name, and then the parameter list inside the parentheses. This takes no parameters, and in this case the entire function is described inside this listing, inside the curly braces. You could have the curly braces with blank space in between, and then the default constructor would construct an object when this function call is made, but it would not assign values to the data members. With the function as written here, we're assigning the value 0 to the width data member and assigning the value 0 to the height data member. The second constructor function also the function name matches the class name. In this case, there are two parameters. The first is a type double number that is assigned to the local variable named double, and the second parameter is a type double number that is assigned to the local variable named h. Now this is simply a declaration of the function. It is not a complete definition of the function. It tells the compiler that we will have a function called a rectangle in this class, and it will take these two parameters, but this does not tell the compiler what that function does. In order to tell the compiler what the function does, it has to be described more completely, as we will see in the next bit of code. Here is the code for the definition of the second constructor function, and it starts with this first statement for the function definition. We begin with the class name and then a double semicolon, and then the function name, and then the list of parameters, and then inside the curly braces is the function definition. The class name is rectangle. The double colon operator is called the scope resolution operator. It tells the compiler that the function named rectangle is a part of the class named rectangle. Seems a bit redundant in this case, but that's the format that is followed with this function definition and with all of the other function definitions that will follow. This function takes two parameters. It takes a type double number that is assigned to the local variable w, and it takes a type double number that is assigned to the local variable h. And inside the definition of the function, let's see if that's on the next slide, the operations performed by this function are described in these two lines of code inside the curly braces. For this constructor function, the function takes the value that is passed to the local variable w and assigns that to the data member of the object that we are calling the rectangle object, the width data member, and then it takes the value that is passed to the local variable h and assigns that value to the class data member called height. So these lines of code describe the operations that are performed by the function. The next two lines of code inside the list of member functions perform a similar operation. Let's call those accessor functions because they give us access to the values of the data members, and they have the format, the return type followed by the function name followed by the list of parameters. And again, this is simply a declaration that these functions will be used inside this class. We have to define these operations completely in other bits of code that will follow in the next bit of the next code fragment. So this is the definition for both of those accessor functions. Again, if you want to see how this is put together with the rest of the code, please look at the example code listing that you can find on Blackboard. They both start with definitions using the same form. For the two accessors, they start with the return type. In this case, I want to return a type double number from each of these functions, and that's followed by the class name. The class name is rectangle. Then the double semicolon operator, followed by the function name. The first function is named getWidth because I want to find the value of the width data member in our class of objects. And the second function is named getHeight because I want to find the height data member. And neither of these functions take parameters. It's simply not necessary to have parameters for the function calls in this case. So these are the function definitions for the two accessor functions. The description of these functions are between the curly braces, and in this case, it's simply one line of code. For the getWidth function, we simply want to return the width data member of the appropriate object. That is returned as a type double number. And for the getHeight function, we want to return the height data member of the appropriate option. And that again is returned as a type double number. Next, let's look at these two functions. They are designed to alter the values of the data members, so we can call those mutator functions. And they follow the same form. They have a return type, the function name, and then the parameter list. And we will use these functions to set the values of the width data member and the height data member. These function definitions follow the same form. The first line is the definition line, which has first the return type. In this case, the return type is void because we do not need to return a value. Then the class name. In both cases, the class name is rectangle. The double colon, the scope resolution operator, and then that's followed by the function name, set width, and set height. These functions will be called when we want to enter a value into the data members of the object, and they both take parameters. Both of them take a single type double number. For the set width function, that we pass the value of a type double number. It is assigned to the local variable w, and for the set height function, we pass it the value of a type double number, and that number is assigned to the local variable h. The operation of these two functions is very straightforward. In both cases, they simply make an assignment to the data members of the objects. For the set width, the value passed to the variable w is assigned to the width data member of the object, and for the set height function call, the data passed to the local variable h is assigned to the height of the data member. The last two functions in this class definition are more general purpose functions. They do a bit of a calculation, or they return some other information about the object. So I don't have any special names for these functions, but they follow the same format as the other functions. First, the return type, then the function name, and then the list of parameters. These are different in that the parameter that they accept is a rectangle object, and this rectangle object is not passed by value, but it is passed by address, by reference. This object doesn't have a single value, so it's not clear to me that you could actually pass the object by value, but you certainly may pass the object by reference. Here are the two function definitions. The first, it has a return type void. It does not return a value to the function call. The name of the class is rectangle, then the double semicolon, and the name of the function is display. I want to display the attributes of the rectangle objects, and it takes as a parameter the address of a class rectangle object, and the local variable name for that object is simply r, lowercase r for rectangle. The second function returns a type double number. It is of the class rectangle, then the double semicolon operator, and the name of the function is diagonal. I want to return the value that is the diagonal measurement of our rectangle, and it takes as a parameter the address of a type rectangle object, and that is assigned to the local variable called r. Okay, so this function definition follows the same format: return type, class name, scope resolution operator, then the function name, and then the list of parameters. And the function definition is in between the braces. The first function that displays the values of the rectangle is described inside the braces, and it does a function call to the console output, and I print out a bit of text for the rectangle width, and then in the same output stream, the r.width returns the width data member of the object referenced by the letter R, and then an end line, and then the second line prints out some text for the rectangle height, and then inserts into the output stream the r.height data member. So the individual data members are referenced using the dot operator. We have the object name, which is r, is the local variable name for that object, the dot operator, and then that's followed by the data member, either the width or the height in this case. And the second function is very similar, except it returns a value. It does a calculation and returns a value. So we are returning the square root of the r.width times r.width plus r.height times r.height. So you can see this is the square root of the width squared plus the height squared. That's simply the length of the hypotenuse of that right triangle in this rectangle. And again, the data members are accessed with the dot operator. We have the object name, then the dot, and then the data member name. Okay, so these lines describe the operations performed by the functions. So we've described all of the functions in the class. Well, first we described the data members of the class, then we described all the member functions of the class. We have access to these data members and these functions by means of function calls that are issued from our main function. So here is the first lines of code in the main function as we would normally see them. It first prints out a bit of text inside the main function, and then the second line inside the main function looks like the declaration of a variable, and it is exactly that. It is the declaration of an object of the class rectangle. So this is an object declaration. The object is of the class rectangle, and the name of this object is box1. This is a function call to our class member functions, and when this line is executed inside the main function, it performs a function call to the default constructor function because we haven't included any parameters in this function call, so it calls the function that takes no parameters, and that is the constructor function rectangle, then closed parentheses, and then inside the braces width equals 0, height equals 0. When this function call is executed, the value 0 will be assigned to the data member box1 dot width, and the value 0 will be assigned to the data member box1 dot height. After declaring an object of the class rectangle and giving it a variable name, box1 in this case, the program then prints out some information about this object. It starts by printing out a bit of text to show us what it's doing, and then the ampersand operator is used to return the memory location of this object. So when this is printed out on the screen, we will see an address location. This is the address location where this object is stored in the computer memory. And then it tabs over for the next piece of information. This line of code prints out a bit of text, and then it performs a function call to the getWidth function, and that function call follows this format. First we have the object name, which is box1, which has been declared to be a part of the class called rectangle, and then so it's object name, then a dot, and then the function name is getWidth, and then the parameters that this function requires inside the parentheses. For this particular function, it takes no parameters, so the function call is simply box1.getWidth, and then open and close parentheses. When this function call is executed, it will go to the class definitions, and it will call the function known as getWidth, which is listed inside the box. This function returns a type double number, and what it does, it simply returns the width data member of the box1 object. So it returns the value of box1.width. The next line of code is similar, except it makes a function call to the getHeight function. So the line prints out a bit of text and then inserts into the output stream the results, the value that is returned from the box1.getHeight function call. When that function call is executed, it goes to the class of rectangles, and it calls up the member function called getHeight. And the getHeight function simply returns the height data member of the object. So this will return the value of box1.height, and that number is then printed on the monitor, and then an end line. The next line of code in the main function is declaring a second object of the class rectangle, but in this case it calls the second constructor function, the constructor function that requires parameters be passed to it. So Rectangle is the function name, also matches the class name, so it will declare and establish an object of the rectangle class. The name of this object is box2, and then the parameters passed to the function call are the two type double numbers 1.2 and 3.4. So when this function call is executed, the value 1.2 is passed to the function and assigned to the local variable w, and the value 3.4 is passed to the function and is assigned to the local variable h. Inside the function itself, the value passed to w is assigned to the width data member of the object, and the value passed to h is assigned to the height data member of the object. So this will set aside memory space for the object called box2, and the value of box2 dot width will be equal to 1.2, and the value of box2 dot height will be equal to 3.4. Then following this line of code is similar lines that print out the address and the width and the height of the of box 2. When the program is executed, this is what appears on the screen. It prints out the text rectangle objects and then prints out the text rectangle box 1. And then the function call that returns the address of the object box 1 is prints out the value of that address location. Then it prints out the text box1 dot width, and then the function call has returned the value of 0 for box1 dot width, and then it prints out box1 dot height, and the function call has returned the value 0 for that as well. And similarly for rectangle box 2, 1.2 is returned for the width and 3.4 is returned for the height. So we have successfully defined these this class of objects, have successfully instantiated two instances of these objects, and assigned values to the data members. The next function call in the main function calls the mutator functions. This function call follows the form of object name dot function name and then the parameters inside the parentheses. The function that is called with this function call is the set width function. So when this line is executed, it calls the set width function inside the class for rectangles, and it passes the value of 5.6 as a parameter by value to the function call. So the function call is executed, the value 5.6 is assigned to the local variable w inside the function, and that value for w is assigned to the width data member of the object box 1. So when this is completed, box 1 dot width will have a value of 5.6. The function call on the next line is very similar, except it is a function call to the function set height. This function call is of the same form. We have object name dot function name and then the parameters inside the parentheses. So it's box1 dot set height, and the value of the parameter is the value 7.8. So that calls the set height function inside our class definition. The value 7.8 is passed to the function and assigned to the local variable h. Inside the function, that value of h is assigned to the data member box1 dot height. After these two function calls are made, printing out again the information for the object box 1, we can see that now the width data member has been set to a value of 5.6, and the height data member has been set to a value of 7.8. The main function then makes a call to the display functions of the rectangle class. This function call takes the form of object name dot function name and then parameters inside the parentheses. In this case, the object name is box1, the function is the display function, and it does take a parameter. It takes a rectangle object, and it passes the reference to the function. It passes the parameter to the function by reference. So when this function call is made from the main function, it calls the display function inside the class called rectangle, and it passes the address of the object box1, and that address is then referenced through the local variable name r. Inside the function itself, it simply prints out a bit of text, and then the r.width data member is printed out, or the value of the r.width data member is printed, and then some more text, and then the value of the r.height data member is printed, and the main function then repeats with a second function call calling the same display function, but this time with object box2 sent to the function as a parameter by reference. When these functions are called, the appropriate information is printed out for the two objects. So after box1.display is called, it displays the rectangle width and the height, and after box2.display is called, it displays the width and the height of box number 2. The last function is called with these two lines of code. The main function prints out a bit of text, and then it performs a function call to the diagonal function of the class rectangle. The function call is of the same form: object name dot function name, and then the parameters. In this case, the object name is box1 dot diagonal is the function name, so that makes a function call to the diagonal function in the class rectangle, and the parameter is the object box1, which is passed to the function by reference, and those values are associated with the local variable name r. And inside this function call, it performs a calculation taking the width, squaring the width data member and squaring the height data member and adding the two together, then taking the square root. Then it returns that value to the function call, where the value is then printed out on the display, and the same thing is the same function call is then made with box2, and the value of the diagonal is printed out on the next line of code. And this is what is printed out on the monitor whenever these lines of code are executed. And feel free to go back and make sure that it did the calculation correctly. You know the length and the width of these boxes, so you can easily calculate the diagonal. So we've successfully defined a class of objects, declared, we've defined a class. We have declared instances of that class as objects. We have function calls to access the values, to change the values, and then function calls to display the values, and a function call to do a calculation with the values. And those all seem to work appropriately. If you want to see more closely what is in the code listing, you can look on the example which is posted to Blackboard.